Hello, everyone. We are Group 16, and we are excited to present our finalized design to you today. From left to right, we have Jawei, myself, Curtis, Luigi, and Ethan. And now I'd like to pass the floor to Jawei.
Okay, so now let's talk about our objectives. So the argument about how much toilet paper used by each person often occurs between roommates. Therefore, our toilet paper dispenser has several things to achieve. This includes reduce the amount of toilet paper used and identify and track who is using the most toilet paper. The machine must be easy to set up and easy to use while keeping the price under $34.99. And for the methodology, we are limited to use the Keypad, Arduino Nano, 4 cubic inches of 3D printer, and the other components included in the kit. Now, Ethan will talk about our different modules.
So for our different modules, we have 7 of them. The first being the interface module, which represents the IoT aspect of the device. Then we have the mid input module, which is the main communication with the TPT. And then the dispensing module, which provides automatic toilet paper dispensing. The motion module, which after a hand is waved, the sensor triggers the dispensing module. Then the alarm module, which when activated sounds an annoying sequence to get the user's attention to replace the empty roll. And then the runout module, which once an empty roll is detected, it sounds the alarm module. And then the processing module, which is used to interface all the hardware components and keep track of time. And here is a block diagram that shows how all the modules interact. Obviously, all of them go into the processing module, but this is just how they all function together. Then for the hardware components, we have the serial interface, PuTTY being the interface module, the matrix keypad being the input module, our modified servo being the dispensing module, which we modified to be continuous, the PIR motion sensor as the motion module, and the speaker as the alarm module, the Hall effect sensor as the runout module, and the Arduino Nano as the processing module.
So yes, for the main software of the device, we have the software recognizing a 4-digit PIN entry, and if it matches a user PIN, the software waits for the motion sensor to trigger, to then trigger the servo motor to dispense the toilet paper. We assign storage variables to each user to track the sheet count, and we also have a master function that's initiated by the pin 2203, which controls all toilet paper tracker settings for the device. For the serial interface, now this is our visual interface between the device and the user. It represents a small LCD display for the user, as well as abstracts the IoT function of automatically sending user updates to email or smartphone. Now, probably the most important sensor for our use is the 3x4 matrix keypad. This allows the user to communicate with the toilet paper tracker. It's a matrix because it has 4 rows and 3 columns, and this positioning allows the microcontroller to know which button you're pressing. We enable pull-up resistors for each column, setting them to a high signal, and we used a function setRowLow to set each row low to a 0 signal every 0.02 seconds, and while scanning at the same time if a corresponding column has been forced low, pinpointing a given pressed button.
So as we said, a typical servo is designed to be set to a specific position and can only rotate 180 degrees. Since our servo is modified, it's modified to rotate continuously, acting as almost a high torque motor. This allows us to dispense toilet paper continuously without a complex ratcheting system and without us being limited by the 180 degrees of rotation.
Okay, so for the motion sensor, for motion detection, we first tried to use the echolocator. Although the code was working perfectly, but we found that it crashed easily while testing. We realized that the echolocator and servo both use the same clock. In the end, we decided to use the PIR motion sensor since it is easier to implement. And this motion sensor uses a passive infrared sensor that detects movements based on heat radiated from the human body. And for the programming code, when motion is detected, an infinite while loop stops and returns 1, triggering the servo to dispense toilet paper.
The sound component that is used for our project is the PAM 8302A with a speaker that is separate from the board that you would need to manually solder. This component is able to play a wide range of frequencies, so we are able to make it play any sound that suits the project's need. For this project, we decided to use it as a sound alarm. So if we were to make a final prototype, we would replace this component with a simple alarm or buzzer. This is because the price for this component is quite large.
So we had originally designed a push button to trigger the speaker, but the weight of the bar that held the toilet paper to spin wasn't enough to press the button. So we actually had to switch to a Hall effect sensor, which works like a switch where it is closed or in the on condition when the magnetic field is present, and it is open or in the off condition when there's no magnetic field present. And this sensor worked very well for the sensitivity needed to detect the roll depletion.
So here's our cost breakdown for our prototype versus when we go into small volume production. The price drops about from $41 to $12 per unit, and here's why. We are able to save costs by buying everything in bulk of 100 quantity and switching the current speaker to a piezo buzzer and printing a custom circuit board. We could consider injection molding to reduce that even further. So here's our mechanical design. It came together mostly as expected. The 4:1 gearing ratio dispenses 2 sheets per second, which is very quick and definitely above what we expected. We were going to hold pressure on the roll with an elastic, but the servo didn't have enough torque to overcome the inertia to get the roller spinning, so we just let gravity do work on it, and that's what pushes it down.
Okay, so for the system performance, at first the keypad reliably detects individual button presses and allows the user to enter a 4-digit password that the microcontroller can compare with the set user interpins. The PIR motion sensor successfully detects movements, and the motion sensitivity can be easily adjusted with the potentiometer. Combined with the microcontroller, the motion sensor reliably triggers the servo motor to dispense toilet paper. And after being triggered by the PIR motion sensor, the servo rotates at the bar at a 4:1 gearing ratio, which successfully rotates the toilet paper roll and dispenses approximately 1 sheet every 0.5 seconds. The Hall effect sensor successfully triggers when the magnet is brought close enough to the sensor when the toilet paper roll is depleted. The speaker consistently produces the program sounds when triggered by the Hall effect sensor. So now pass to Luigi to talk about the rest of the system performance.
While integrating all the components, we ran into issues regarding pin allocation, which we promptly resolved. We also decided to swap the ultrasonic sensor with the motion sensor, as it was using a timer needed by the servo motor. Both sensors work to achieve the same thing, so this was not a problem. In the end, our integrated system worked without problems. To test this device, the following steps were taken. We inputted a PIN code on the keypad, followed by waving a hand over the motion sensor to dispense a toilet paper, and finally press 0 on the keypad to exit. The settings were tested as well on the master function, which has a default PIN code of 2203. All of the modules work seamlessly and produce a consistent result. So now we are in our conclusion. Our device is useful because it is an improvement over the classic toilet paper dispenser. It has extra features such as identifying and tracking the toilet paper used by a user, and can also notify the user when the toilet paper is fully depleted. Our project has also fulfilled all of the objectives that were outlined. All of these functions act in a consistent manner, which is ideal. Our device can be used in any bathroom environment. It can be used at a home with a small group of people, or it can be used as a toilet paper dispenser in public and commercial bathrooms. In the future, our group is planning to make several modifications. We plan to replace the serial interface with a different visual display so that a computer is not needed to use your device, design some software so that information produced by the device will be stored on a phone, replace some components with cheaper alternatives, implement all the components on a custom PCB, and producing the device in a larger scale. Finally, we might consider making a device that can accommodate other types of paper rolls. This marks the end of our presentation. Thank you for watching.